Okay, so it does save properly and all that. Alright, so if we've got our height map going on, for all this shenaniganry, so the question would be, what kind of information do I really need for this texture? Like, do I need the depth of the water, or do I need like the distance from shore? In which case, I would actually want like for every pixel, I'd kind of want to figure out where the closest shore was, which we can't really do in the pixel shader. We'd have to pre-compute that. And shore is going to be a 0 on these. It's going to be something that's black on this texture. I think I do need the distance from shore. What would we do with it? Well, we'd be able to say like, well, the distance from shore and then something else in order to make sort of stuff, as opposed to having a just a depth. We could have a depth and a distance from shore or something. Well, I like the idea of having the information available. How would we calculate that distance from shore inside of this? I mean, we would just basically run through every pixel and try to find the closest black. I mean, could we just go in a straight line? We could go in like just 8 directions or something. It should work pretty well for figuring out where the closest shore is. Let me think, is there some sort of algorithm that we could use in order to find the closest shore? Like if we started off and we're going in from like, top left to bottom right, we could calculate the closest shore by like we could go in all directions. I mean, we could like look up our neighbor or something and be like, where's the closest shore? Trying to think, like, if we had a whole bunch of grid squares, like, and we went from left to right, we could basically say, like, if this is shore and this is shore and this is shore, we could, like, if we're on this pixel, we could say, okay, we are shore, distance is 0. This guy could say, hey, what's the distance to shore? And it'd be like, oh, you are shore. Okay, so the distance is 1. And, go in 4 directions. This guy would say, what's the distance to shore for you? You would say 1. You go in all 4 directions. And this guy would say, oh, what's the distance to shore? Oh, it'd be 1. This guy would look, and if we went in 8 directions, he would say the distance is 1. This guy would look over here, and he would say, what's the distance? Look over here, say, what's the distance? He'd say, I don't know yet. It'd be like, it would say, 1,000 or something. And this guy would say, okay, well, the distance to shore is going to be 1. And let's say we had this sort of thing going on. Or this guy would say, what's the distance to shore? This guy would say 2. This guy would say, okay, 1,000. Okay, this will be 3. And let's say this guy was shore. Then that would be wrong because the distance should be 2. I guess what I could do is I could do a different algorithm. I could start on these pixels that are shore and just write in the directions and say like, okay, the distance is 1, 2, 3, 4, 5, and then go to the next thing, and it would be, okay, the distance is going to be 1, and then start again. It'd be 1, 2, 3, and if we kept going like that, if we went in all 4 directions, would it matter? We could iterate over it and then like iterate over it again or something, and basically you'd be replacing with the lowest value. So, with 1, 2, 3, and this would be 0. Yes, it'd be like 1,000, 1,000, 1,000, 1,000, 1,000, nothing. And then if we went through in all 4 directions, like then we went down, and then we went left. Would that work? Would that cover every case? If we just, and we're just iterating over 4 times with decrementing values for distances, and we could get the distance to shore. So it would that matter? So would this block cover this one? It'd be like, no, it wouldn't. Well, let me think. And we could just do a maximum distance, and basically for every pixel here, you would just look at all the surrounding pixels. So, you basically just, okay, replace the distances, and keep going out. The only problem is for every single pixel, you're having to do an n-squared algorithm for it. But we don't care about the distance. So let's think, if we did this iteratively, how would it work? we'd want this pixel to be able to fix this thing. So if we were going to the right, and this guy would say, if he looked, it could write in the values for all the other pixels around it. So if the algorithm was we write the values into the next column, so what we'd do is this would write 1, and this would look at itself and say 1. Okay, I should write, look at all the surrounding pixels. This guy should write 1, 1, and this is a 0 already, so it doesn't matter. It's going to write 1, then it's going to write 2, then 3, 4, 5. And this would write nothing. It would write 5. Okay, and this would this one would write 0, so it would go, okay, this should be 1, this should be 1, this should be 1 here, 0, and this guy would be 1, 1. This guy would write over here, he would write 2, 2. It would then write 3 here, and then 4, etc. But we wouldn't get this guy to write up. He wouldn't fix this. This should be a 1. How could this be a 1 though? And we could basically have an algorithm that picks the surrounding pixels and writes them if the value is lower, so the algorithm is modified so that when you are a pixel, you look around to all of your pixels, and if it's greater than yours, then you write it. So we would keep going to the right. This guy would write 3, this guy would write, this guy's already a 1, so he's going to write nothing to himself. He's going to write 2, 3, 4, 5. This guy would then come back and write 4, 3, 2, 1. I mean, he would write 1, 2, and this would be 1 already, because it was already written. This would be 2, 1, 2, 1. This guy would write a 1 in here, would write a 1 in here, and then this would be a 2, so it wouldn't do it. This would be a 2, so it'd stop. And this guy would write a 2 here and then stop. Okay, so if we just have an ever expanding field of stuff, and we stop when we do. Okay, we could totally do this then. And probably the best way to do it is some sort of iterative process to kind of detect the shore pattern, and we'll write the distance to shore as a float, I believe. All right, so let's do that. I think it's going to be necessary. So the distance to shore texture is what we will create here. It's a new one. Alright, so this is going to be our distance texture. And this is going to be a texture 2D reference. This is our distance to shore texture. Okay, so we have fill height array. So this one we probably want fill height array. The output is an array of colors. We could actually set our distance texture in here as well. And if we change this fill height array, and we pass a boolean in there to get the distances. So let's go ahead and do that. Alright, so fill height array. Our bool get distances, and we're going to want a T array of distance output. So let's write it. Let's get it written. Alright, so we're going to have if get distance, then we are going to calculate the distance. So what we want to do is, our algorithm is iterate through pixels, select the current pixel, try to expand in all directions, add all pixels to our list. So it's basically like open a pixel, I mean, it's basically kind of like A star. It's kind of pre-compute A star, but it's not really, because we're not, I mean, it kind of is. It's like distance to every other point or whatever, but instead it's like distance to some, arbitrary idea. So do we want to do this on the stack? Or do we want to do this iteratively? I guess we could do it on the stack. So we could do like this private, so it'd be like static void calc height, calc distance pixel, and we want int32 x, int32 y, int32 width, int32 height. We want the fcolor, the T array for the heights, and we want the T array for the distances. So this will be heights and distances. Alright, so what we want to do is we want to go through for everything here, and we're going to open every pixel. We're going to calc for every pixel and then recursively calculate surrounding them. So we'll do calc distance pixel x, y, width, height. Let's see, output, and then distances. Alright, so what we want to do is we want to, the T-array F-color distances should be like max distance. And I guess max distance is going to be like 0 to 255, pretty much. Can we do anything with F colors? Alright, well, regardless, we need to init this thing, and the distance is going to be initialized to, I guess, what, 255, 0, 0, 0? 0, yeah. So we need resolution X, resolution Y. And this is distance output. Okay, so it's going to start at 255. So what we want to do is if our pixel is ground, then we want to start this process of expansion. So we want to get our current thing. So f color cur equals heights sub x plus width times y. Yeah, so if x is greater than or equal to width, then we can just return. So it'd be if x is greater than or equal to width, or x is less than 0, or y is greater than or equal to height, or y is less than 0, then we stop. Alright, so we'll get our current f color. So cur dot if the distance is 0, so the distance is the A channel, so if A is greater than 0, then we're going to return. I think we need to pass in an int 8 here, which is going to be our propagation. So we're going to be passing in a propagation of 255, so that'd be max. So this will be int 8 propagation. Is it propo or propa? It's got an A in it. That's what I thought. Alright, so if if cur.a So how does this work? It's basically like, okay, we've opened this pixel and we've opened it with a propagation value, and if the current value is lower, no, this is a distance. We want to know if we need the current value of the yeah. So the current height, and we'll have f color. We're gonna have current distance. It's distances sub x plus width times y. All right. So if the current distance dot r is less than propagation, then we return. So we run into something that's closer or less than our current value. I guess less than or equal to. So we're like 2 3s that have hit each other. So it's like, oh, well, we're fine. Right, but it's basically if cur.a is equal to 0, then we're going to want to open all the pixels around us. So we're gonna, it's gonna be like x plus 1, y, width, height, heights, distances, and then the propagation value is going to be 1. We're going to say like so it'll be x plus 1, y plus 1. X minus, alright, so it's like top left, middle, top right, and then we have the one to our left. We don't need to open up our current pixel. And we'll also write our this will be a reference, so we can actually go ahead and mess with this. So we'll open up all these other pixels real quick, and that'll start off all the rest of this recursive stuff. Otherwise, we will check our current stuff. So this will start all these things if our current height is 0. So if our current height is 0, we're good. If our current distance is less than or equal to our propagation, we should be fine. We'll return. Otherwise, we need to, this will mean that our current distance, our propagation value is fine. So what we want to do is we want to open all the things around us. Alright, we would say current distance dot r equals propagation, and then we would open up all these, and it would be propagation plus 1. I mean, so this is basically saying like it's basically just saying this. Propagation equals 0. So I guess that's the code. Let's see if it works. It should give us the distance from shore. It's kind of an expensive algorithm. It explodes all over the place, but it at least stops if it runs into stuff. Yeah, I guess it's else if propagation is greater than or equal to 255 or return. It should be a uint8. So just compile all this stuff. And we'll see, processors are pretty quick. We should be able to chew through this probably faster than all the damn raycasts. But we'll see. We'll see if this is a super slow, expensive pile of garbage. First thing we're going to do is we're going to hook up our textures so that we can actually pass it in here for our materials for this thing. So let's do that first. So get our texture here, our distance output. Alright, and we're going to want to copy paste this stuff over here. And we're not going to want to set the height map, we're going to want to set the distance texture. This will be static distance. And a height map resolution is going to come in there. The root value needs to match. Get our distance texture. Alright. See, what's this all pissed off about? Yeah, it's pissed about this distance output stuff not being there. Alright, so now we're going to go into our material. And our test texture is the thing that we can actually look at. So it's actually inside of our setup shader parameters. We need another, we'll duplicate this and it'll be like test distance map. So toggle this to view the distance map. Alright, so test distance map will be in here if it's true. Let's just do all this. So if this is true, we're going here, otherwise we're going here. And then this false, just, well, if test dynamic obstacles is true, it should go here. We should hook it in right there. Alright, so we should be able to toggle all this stuff. So if we go over to this object in the level, should be able to uncheck this and then check the test distance map. And nothing's getting put in there? Oh, yeah, I've got this OR structure here. Alright, so toggling our distance map should do it. Alright, so let's make sure we got everything saved up properly. And let's walk through our algorithm. Let's go ahead and get this static height map construction going on. Alright, so what we're going to do is x is 0, width is 1024, all that. So we're going to put the current height. Heights, so 0 is going to be 255 and all that. Got distances. Distances are all 255s. So current height dot A is 0, so propagation is going to be 0, which means we're going to go in and open up all these things. How deep are we? Real deep. X is 0. Y is really, really big. And what is our propagation? Rayful is optimized away. Current distance. Oh yeah, I'm gonna go look at that. Well, let's just walk through what we can and see what we can do here. Current height dot A is 0. This is just annoying how the breakpoints aren't working. How come it shifted these things? Yeah, we can't, actually have breakpoints. Y is 2048? What? X, Y with height. X, Y with height. What? How in the hell is the Y 2048? Y is 5120? Y is 6. Y is 6144? What in the hell is going on here? Is the Y really? What? Well, let's just build some of this stuff and see how it looks without the recursion real quick. It should at least draw the zeros in for the R. Heights, distances, propagation. What's the material actually drawing at the moment? The material is drawing none of this. Let's check this out. Alright, so we do have the blacks and the whites going on there, so that is correct. And those pixels are, yeah, right there, proper. So those are the distances, and those are where they should be starting the propagation. Well, let's change the height map resolution to something, like, 32 maybe. Anyway, I'll be right back. Alright, so we're just going to save this out real quick. Alright, so I'm going to say if the propagation is greater than like 6 or something like that, then we're going to return. We'll see how this works on a smaller scale. And see if it's like, well, you know, we can't use the stack for this. We have to do an iterative algorithm, not a recursive one, because, you know, there's too much. In which case, we could have like a maximum distance step sort of thing in there. You know, we could just deal with that. We probably don't need nearly as high a resolution on the distance map. Or at least we can do a few tricks maybe. How is y 992? What is going on with this y value? Should be xy with height and everything else. I do not see current distance dot r is less than propagation. This is just really odd why the y value is doing something that it shouldn't. I mean, it's probably the debugger lying to me and saying the y is a value that it isn't. Oh, alright. I see what's going on here. It's like going back and forth on itself. So it's looking up inside of itself to say like, oh yeah, the current height is this. If the current height is 0, alright, the propagation is 0. Okay, so what we want to know is if the current distance is already 0. So that'll tell us if we already visited this pixel. Yeah, it's basically going back and forth with the pixels that were already black and just dinging forever, and that would cause the Y to go real high and everything like that because it's just doing crazy shit. Yeah, that'll do it. Alright, so propagation is 0, so we're going to calculate stuff. Propagation was